Yes. So next up, we have a keynote. So our keynote speaker is Dawn Wages. So I met Dawn a couple of years ago. I met Dawn a couple of years ago at through DjangoCon Africa. So she was one of the organizers, and I was one of the organizers. And I had no idea who she was at the time or how hardcore she was. I was just like, she's really helpful. And it turned out that she was the president of the Python Software Foundation. She's no longer. She stepped down very recently, very, very accomplished individual, really cares about the African community, has stepped in to the African community and made waves in some pretty big ways. So I'm grateful for her existence. Yay. Could you all welcome Dawn to the stage? Thanks, Dawn. Yes. Yes, Dawn is going to be talking about the Fellowship of the Stack. There you go.
It's such a pleasure to be here. Thank you so much, Sheena, for the really warm introduction. And this is my first time in South Africa. I've been on the continent a few times, and it's always been such a warm welcome. And I'm going to be joining the Discord and joining some of the social activities. So I hope you all are doing it too, and I'll get to meet more of you all in the hallway track. So again, my name is Dawn Wages, she, her pronouns. I came all the way from Philadelphia. And I'm going to do a little bit of interaction through this talk, so I hope you all are awake. Maybe some jet lag has gotten you from depending on how far you came, but I'd love some hand raises. So how many in this audience are familiar with scientific Python? Good group, awesome. So it's an ecosystem, a loose federation of community that develops its own projects in pursuit of scientific discovery. And in this pursuit, we find ourselves needing similar things, and thus we band together to go farther. And this is a story specific to scientific research, but if you are in the general Python community, maybe you do web development or data analysis or some other Python applications, this could also be a similar story, a story of going farther together. So who am I? My name's Dawn Wages. I am, let's see, what are all of the things that I said about myself? I'm just a guy in the ecosystem, but I am the outgoing chair of the Python Software Foundation Board of Directors. Shout out to Sheena, who, as I am leaving the Board of Directors, Sheena will be coming on. And so you have representation right here in your backyard, influencing the direction of Python. And I'll also talk a little bit more about some of the funding implications that Sheena mentioned in this kind of going farther together story and how you can be involved with that. I am the Director of Community and Developer Relations at Anaconda, and so if you want to talk data science or our new products that'll be coming out, I'm chatting with people about just where they exist in the ecosystem, and if you want to be part of that that new wave, please let me know, and I'd love to chat with you. So, if you have your phones out, I would love for engagement here. These two ways are how I know that my impact in the community is actually doing something. And thankfully, both of these have been going like gangbusters, but I want you all to be a part of it. So the first is being a Python Software Foundation member. There are two ways to become a member of the Python Software Foundation. These QR codes will come up once again near the end of the presentation. But being a member is a point of pride for many people. I have a goal of increasing our membership by next year. I do a fair bit of traveling and talking, and so join me next year this time. There's going to be an election cycle, and I'd love for you to join the entire journey. The next is the Python Packaging Ecosystem Survey. It is the first of its kind. We started a couple different times previous years on starting a survey for packaging. If you're familiar with PyPI or anaconda.org, in the last several months, there's been a banner on the top of both of those package repositories. It's the same survey. We currently have 16,000 respondents. I think it's about 17,000 now. The survey ends ends at December 31st at the end of the day anywhere on Earth. But I'd love to have your voice represented. And this has been organized. It's sponsored by Anaconda, but there's a group of 30 plus contributors in the ecosystem who help come together for this packaging survey. And so if you've ever pip installed or used a Docker image that automatically installed packages for you, if you've ever apt-get, you are in the audience of people we want to hear from. So experience is not going to be a barrier for contributing. All right, so let's get into our epic journey. We meet our first friend who sings a tale of what's possible to inspire us on our journey. Through the presentation, we'll talk about scientific discovery, and always it starts with a spark. This journey will start with understanding why Python ecosystem is so treacherous to maintain, and I posit that for two reasons. I think that one, it's because of the evolving nature of software. We are in a critical inflection point in software development because there's been incredible investment in making sure the development process is easier for us. It is a era of IDEs, VS Code, AI assistance, and so the developer experience is one that we are iterating on, and we get to be a lot more choosy. Secondly, I think it's because you can do so much with Python. So since the early 2000s, there was an era of proliferation in the Python community across the world. And because of that, of Python's readability and ability to abstract away from machine level programming considerations, you were empowered to build faster. And thus that would bifurcate or continue to split the community in different directions because you're building on your own and you could build faster. It provides immense amount of good and also allows for a very diverse group of developers to create their specific scenarios. I mentioned that due to PEP 772, that would be the Python Packaging Council that will also continue to support the Python Packaging Ecosystem Survey. I hope to demystify some of the ways that people can contribute to the ecosystem. And then I also would love to employ you to get involved. It helps to get your feedback and be opinionated. So people who do invest in the community and to the tools that you use, this could be you, will understand and have that feedback loop to the users. So let's plot our course. If you're following the extended metaphor of this presentation, we're going to get our supplies and then cast a few spells. We're going to meet different people along our way on our journey, and then we'll look at some of the trials we'll run into as we scale our quest into larger and involve more considerations. And what you'll need. So let's start from the very beginning, regardless of your experience, and then it'll get a little bit more complicated. We'll also talk about understanding the Python interpreter as well. But we start with a language interpreter, which reads your source code and translates it and executes it. That could be Python or Jython. CPython or Jython. There's IronPython or PyPy. These are all different distributions of Python with different considerations. Your package manager accesses the repository of packages you need. This could be a Python package manager, a language agnostic one. You have your development environment, which creates a sandbox for your project, and sometimes that's connected to your virtual environment, and your version control, which will track its progress over time. You have data that is necessary, and if you're not using data for your scientific computing scenario, you may be doing that mathematical modeling, leveraging optimization system parameters, controlling experiments, and other types of observational phenomena. The last two, I think, are pretty unique to the discipline that you are in. This is understandable if you are interested in improving the developer experience. The exploration and analysis functionalities are some of the same packages. I'd like to note that that data exploration will tell you what you have, the shape of it, and clean it if it's missing any context, while the analysis is going to help you start identifying some of that missing context. It'll help you have hypotheses, build predictive models, and then create some of those inferences. So we stumble upon a guide and a shopkeeper, a warrior in their own right who experience in some of the essential tools of the trade. Many of these icons are metaphors for things you'll find in your toolkit. We'll have an IDE, your interactive development environment, that will transport you to another realm, keep track of your system variables, and make sense of your universe across files. You'll have tools to provide health checks. For example, CondaForge and Mamba have environment health checks. You can do hypothesis testing, that is a health check of sorts, and data alerts on your data pipeline. You can identify data drift, for example, or validate your data quality. And how about this twine? It looks like a simple ball of thread, but it holds your code together. For those who may know the reference more literally, Twine is the tool under the hood for GitHub Actions. So you can keep your code together as it goes from one environment to the other. And don't underestimate good code formatters and linters, style checking and organizing your imports, or security-focused linting like Bandit. And your spell book, your documentation. You start with writing spells. You can recite them truthfully every time you need to sit down and embark upon your own journey. But soon expand that spell book so it can be used by others. You can share it freely and reduce the barriers for your fellow journey people to reach the levels that you have. Specifically with scientific computing, and as I've talked to thousands of developers over the years, version control is not something that's always intuitive for people who get into Python through scripting, but I like to think of it as a time machine. It's easy to jump back into your code and justify why we can have version control by going back in time to seeing what you did previously. And data. The magic of data is digitized gold. So I want to poll the audience, another interactive moment. How many of you are using languages other than Python in your development? That's a good chunk, maybe like a third. What about if you're approaching a new project? Are you scoping out your architecture beforehand, doing a lot of pre-work, for example, your packages or your environment dependencies, or are you encountering the issues and solving them linearly? What about the hands for the first? Who's doing a lot of scoping before you start programming? And what about the second? Who tries to just go head first and runs into problems and pushes through? All right, a lot of the latter, I see. And last question, do you know from the outset whether or not you'll be sharing or collaborating with your with peers for your projects? Let's say hands for yes. Do you know if the collaboration's involved? Or what about those who won't know and figure out the shareability of your project later? Hands? All right. Seems like we have a little bit more of the former on this one. So this is a typical kind of journey in data preparation, data understanding, modeling, data science scenarios. You'll starting with your domain problem and you'll scope that problem to understand your data. Then you'll prepare your data for usage and cleaning. This is also called data wrangling, and you can have normalization within that process as well. Then you'll model your data with data science variations of scientific computing tasks where you can understand some of the relationships and make predictions. And then you'll optimize that current processes. The end of that evaluation process is production results. This could mean very different things depending on what your use case is and who the audience you are developing for. We made a new friend. We've stumbled across in our journey a friend of knowledge, driven by its pursuit. They are wise in many years and very magnanimous with their knowledge. They're well-versed in the new and old magic. They hear about your journey and are immediately interested in helping. So there's many ways that people have used Python. It's a huge ecosystem with hundreds of thousands of packages, and you are able to leverage those packages to accomplish what you may be looking for, speeding up your time to the end of your journey. There's the first generation in roughly the mid-1990s to the mid-2000s. There was a emphasis on Python's integration and ease of use as a compiled language. There was a F2Py, which would be like Fortran to Python, Swig, and later CPython. And that emphasis was on array-centric computing that allowed for enabling mathematical operations in entire arrays without explicit loops. These were also predominantly free tools as opposed to the expensive proprietary tools that predated this, and many with academic and research origins developed by scientists for scientists. In the new generation, our friend of knowledge will tell us that there are rising stars in the community, like Polars, which just recently hit 1.0. There's an emphasis on performance, like Polars and DuckDB. There's also a fun one that I've been playing with, which would be NVIDIA's Rapids libraries, which allows for GPU acceleration. And then there's an emphasis on ecosystem integration. So looking at packages like scikit-learn and plotting libraries that work through narwhals as a compatibility layer. A lot of the themes that I see popping up in this new generation of packages are like distributed computing with Dask, emerging visualization tools, a performance-first approach, and then a zero-code change philosophy. This enables the democratization of machine learning, and it's becoming more sophisticated. And as many people know of the AI that's all over, it's being put in everyone's hands, and we are all a step closer by being in this room and collaborating together. So we have a new friend, a warrior of valuable skill and fortitude. I think one of the key insights of working with this new team member who brings something to the crew is that there's a unique balance in scientific software where it must solve two purposes. It must produce correct scientific results, but it also must be maintainable as a software system. And so this dual requirement makes the principles especially important for the scientific Python ecosystem. And maintaining software systems are not easy. So one of the adage that I use is you need to get results quickly, explore ideas, and publish, versus the software engineering principles of build it right, make it last, and keep it clean. I do want to do a highlight at the bottom. There's PyOpenSci for people who are interested in the scientific Python community but are new to software principles or Python packaging and Python environments. It's a really warm and welcoming community that lowers the barriers for people to kind of start from their subject matter expert discipline and then transcend into some of the software complexities. And now we get into some trials and tribulations. I've mentioned Python like it's a given, but maybe I've alluded to some of the benefits of why Python is the language franca of science these days. It's been chosen years over years in the community, and it's been born to support and continue to invest in and has thrived because of it. It is a glue language, which means it's very variable. It is many times in between maybe a Java backend or a JavaScript front end. And that interoperability and also the ability to offload bottlenecks in compute like to C or C++ has made it a really good second best language for everything, which makes it a very common language for everyone. I'm a Pythonista, yes, because I enjoy my community, but it's also an alignment of incentives. Without a really dogmatic approach, the second best language for everything has also risen to the top. And we have a side quest and a new friend to help us traverse that. Let's talk a little bit about the Python interpreter and how your code actually runs. So there are other Python interpreters. As I mentioned, there's Jython, which is written in Java, IronPython, which is written for .NET, PyPy, which is a just-in-time compiling interpreter. These all directly execute the code rather than needing a separate compilation step. This would be if you are hitting like Shift-Enter on your python.main or your CLI. And we've met a friend here who is going to help us through that process. Your code, the code you write in Python is converted from your machine code by the Python interpreter without any physical compilation. This is all human readable code, humanish, where Python is performing the lexical valuations, breaking down each of these characters into tokens along with keywords and identifiers and operators. And that will represent the shape of a code, and it'll make a language tree. This means you don't have to compile the code like you would need to do in Java, C, or C++. And that interpreter takes and executes each statement in the written code line by line. This program will check if there are errors by the Python compiler, and then the compiler will find the error and then show the error in your console. Many of us who have traversed into the console are familiar with their first scary error. That's at this point where it runs. After the lexical evaluation, the interpreter will parse that code and then make sure it will conform to that summary syntax tree. Now we're at the bytecode, which is a low-level platform. It's platform unbiased, and it's a representation of that source code. The compilation of the bytecode is accomplished by that Python compiler. And then the bytecode is then processed inside that Python virtual machine. And it's being interpreted to give actual machine code. And so this is where the portability of the source code is valuable. This Python virtual machine allows for things to happen at runtime, like dynamic typing and runtime introspection. And this is where I was discussing some of the interoperability of those other languages. There's a very nice extension, the C API for C, C++, Fortran. You can do all sorts of fun things, which makes it relatively easy to lean into some of the performance improvements with Python. It does talk to most things. You don't have to choose between Python and your other favorite language. And once we have machine-readable code, the interpreter never produces any intermediate machine code, unlike a compiled programming language. Python is easy for the development environment because of the way that it can share the source code and be interpreted dynamically. This also allows for you to write code in all sorts of ways and have all different types of tedious and difficult dependencies, and Python's interpreter will just try its best to handle it. And when people are distributing Python programs, they're distributing that source code. And one of the reasons why I wanted to get into how the Python file to machine code actually works is because that adds a level of complexity when supporting and creating your Python development environment. This is also a through line into packaging complexities. It is non-trivial to manage your packaging ecosystem, and we've met a friend who is an expert and a nuanced in packaging complexities to help us through the way. Combining utility and reproducible and distributable version-controlled way to allow for iterative improvements. Python sometimes packages will build differently based on the date. Bugs in GCC that leads to loss of numerical precision based on import order. Correct configure scripts, which could sometimes be in Perl, a different language. Or shared symbols that can delete references and between versions silently. Never have anything be deleted silently. That is very scary, and hopefully it gives fear into the hearts of all of you in this audience. For example, GDAL, which requires building Chromium, or file system issues, or across architectures. For example, Pillow, an imaging library, relies on pre-built wheels, which aren't always available, which requires a C compiler and development headers. As I mentioned, GDAL, which is the Geospatial Data Abstraction Library, is notoriously difficult. It's a complex geospatial toolkit that requires a bunch of different formats, and also requires proj, geo, SQLite, Postgres, geotiff, shapefile, a lot. And when we're discussing some of these operational realities, these stem from technical necessities. It's the way the ecosystems grow. It's no shame on any particular maintainer. We're pulling things together to facilitate scientific development. And many of these maintainers kind of know and are actively collaborating on some of these solutions. If you've seen a pull request that's solving any of these as I'm talking, find me out in the hallway track and I can update my presentation. For example, matching PyTorch versions with your CUDA version. PyTorch ships with a specific CUDA version baked in, and there's a huge download size, and there's strict compatibility requirements. Another of which, an example notorious in the community that's difficult to traverse. So now we have magical sibling sisters that requires you to make decisions before you can employ their services. They've seen it all, and with them, you're able to get deeper aligned into your domain problem. You're starting with general purpose, and you're going to want to move into broad scientific, domain-specific, and then lab or project-specific analysis. These tend to be problem-driven and aligned to your data types and formats and incorporate domain nuance that allow for intradisciplinary collaboration. Although interdisciplinary among multiple disciplines are external to the discipline, some of the solutions that could apply to other categories may be less discoverable. So, our fellowship is forged. It is 2025 in scientific computing, the underpinning of AI, and some trends I've seen emerge. I've mentioned before, and I've spent a long time, past maybe 4 or so years, talking to thousands of Python developers about their development environment. That's between being on the Python VS Code team and now in my position leading developer relations at Anaconda. And some trends I've seen are emerging and proliferating. And I really love doing presentations where I talk about trends because developers like to know what other developers are typically doing. So when it works, you may not notice when your Python distribution is not CPython. And I'm seeing more proliferation of people being interested in other Python distributions. For example, UV has its own Python distribution. People like development environments. I do have a friend in the front and some other holdouts who are still in their CLI, and that's okay. I love Emacs and in your terminal, but there's a huge investment in IDEs, and they're lowering the barriers, especially when you see AI assistance in these IDEs. If I can get a show of hands, who actively uses currently an AI assistant in their code? Okay. And then who would, if they could, if it was available, if it was free, who wants to? Okay. So it looks like most of the people who want to use it have access to it and are using it. And who is like, I don't want any AI in my code, leave me alone? All right. I respect all viewpoints on it. I'll be honest, I was AI agnostic for a while, and even now I'm pretty reticent, but I really appreciate the ongoing conversations we're having in the community, being pragmatic about it, understanding its impact, and recognizing where there needs to be a human in the loop. People are really interested in tools that are orchestrating your workflow. And for example, a lot of our package managers are doing project-based approaches. As if you're interested, it's a little bit of a tangent, but I recommend you look it up. A lot of our tools are using that as a paradigm these days. And it's agreed across the ecosystem, specifically in Python, there are too many environment standards and artifacts, and there's a huge proliferation in tooling. And so this is also part of the reason why we are doing the Python packaging survey and why there were so many people who were interested in participating and organizing it, is because we're looking to come together on a standard. For people who are interested and like to wonk out on Python enhancement proposals, I recommend you look at PEP 440, PEP 621, and PEP 518, and that is version identification, project metadata, and build system requirements, respectively. I recommend you wonk out on some of the PEPs. They're actually pretty fun to understand how some of the ideas in Python come to be. So, we've made the journey. These are our helpers. We started our journey. We met a friend who showed us the way and inspired us to believe what is possible in our epic journey. We met a shopkeeper who showed us the tools, a sage friend with deep scientific knowledge of the old and new ways, a formidable warrior who equipped us with software engineering principles for resilient code, two deeply technical companions, one to help us navigate the Python interpreter, and the other to dodge the perils of complex package dependencies. And the last but not least, our friends to help us with deep domain knowledge. They know the dark arts of every form and can help us navigate our domain nuance. So if you want to scale your quest beyond what I've discussed, some high-level, just kind of buzzwords that I think you should do to make your code more resilient: observable, monitored, logged. You'll have enhanced collaboration features. One of the things I love is mob programming. So if I don't know if it's still in fashion these days, but like a quick weekend where you get a couple of friends and you're all working together on the same file, it's kind of fun when you have these tools. If you all remember Cloud9, which AWS had, and now I don't know the tool chain exists. You can run on specialized architecture like GPU enabled. And I could make a whole presentation on productizing for production, but it is the idea of putting yourself in a product manager's seat when you are delivering these tools for your peers for collaboration and creating great documentation, having an enjoyable developer experience, things like that. Modular workflows, and also make sure your code is documented. So with the PSF, if you want to scale the journey with the PSF, voting has already ceased. I should have taken this one off. But if you become a member, there are two ways to become a member, as I mentioned: as low as $25 US, or $5 of investment, either in community. So who all has volunteered for this conference? All right, I see a few hands. You all are eligible to be PSF members if you do on average 5 hours a month. And this conference is not easy to pull off. And special cheers for people who did it. You can join as a Python Software Foundation member, and then you can vote in the next upcoming election, and then funding the Python community we'll chat about. These were the dates of the most recent election. You can join as a Python Software Foundation member. I'll pause on this for a second if you didn't get it before. This is the QR code. And then funding. So we chatted a little bit before about funding complexities in the PSF. Python is the most popular language in the world. So why is the Python community having trouble funding events that we know are important to the ecosystem? A little bit about me. I started my Python journey because a Python conference came to my city and I joined a Django Girls event. It was wonderful, humble, beautiful beginnings. I've made tons of friends, some of which are like pivotal to my circle right now. But how do we continue to keep that momentum going? It's a convergence of several different things in the PSF. This is us being considerate of the headwinds that are coming. If conferences are expensive, and a lot of your communities will sustain investments throughout the entire year based off of the success of the conference. And conference costs are just going up. There's also a translation layer. It's one of the things that I am specializing more in as I get more advanced in my career, of trying to talk to these companies and translate the good that we see on the ground in the community to value that you provide for the sponsors who may show up. So as Sheena said at the very beginning, go to the sponsor booths, show them that we are active and supportive and that they should come back next year. One of the things that I really like to do as someone who sponsors conferences through my organizations is have user feedback during the hallway track. Make sure that you are able to engage. This is a note that there is a pause on funding grants from the PSF over the next year. The faster that we are able to turn up our sponsorship muscles and pivot and articulate the value of the community to supporters of the community, the better we're going to be able to come out of this really tough time period. So, thank you so much. This was a great job. You have officially unlocked the secrets of scientific Python. This is one more slide about where this analogy falls short. Documentation exists, and it's not dark magic. We iterate, and it's not one long journey. And you don't have to understand the entire ecosystem to be successful. I wanted to give a special thank you to Riska, who created this art and inspired me to take what was once a very technical talk and make it more of a narrative format. And this is me, Take the Python Packaging Survey. Thank you. Did I run long?
I think it's fine. We had our timekeeper there in the front. It was all good. So thank you so much, Dawn. You were wonderful. And this is why I care so much about things like Django Girls and Humble Data that we did yesterday. Who went to those? Just show of hands. Yes, okay, so a couple of you are around. That's fantastic. Yeah, so I hope that you're inspired by that story.